In many cases, we are asked to determine if the function is even, odd, or neither algebraically. But how do we do this? Since we already know the end behaviors of the functions, we know a couple of things. So let's start with our even function. In our even function, let's say we have f of x. If we plug in a negative x, we know that f of negative x is going to simply be f of x. Meaning that regardless if I plug in a negative number, I'm still going to end up with a positive value. Now with odd functions, if again I take my f of x and I plug in a negative x, in this case, we result with a negative f of x value. Thus, the major difference is that whenever I start with an even function, I typically end up with the same thing. But if I start up with an odd function, I end up with a negative of the whole thing. So let's put this into perspective. Let's get some examples to clear things up. Let's say my first example is going to be f of x is going to equal to negative 3x squared plus 4. One of the things that we learned before is the first thing to identify is if this can possibly be an even or an odd function. So we look at the x with the highest exponent. In this case, it's at 2. And we know that 2 is an even number. So this is actually an even function. That's what we initially assume. Now to actually test it out, what we do is that we plug in an f of negative x, okay? So we plug in this negative x into our function instead of the x to see if we're gonna get the same thing. Because remember, like what I said before, our objective is to end up with the same thing. So we know that our even function, if it actually is even, we are going to end up with something that looks negative 3x squared plus 4. This is our goal. If we end up with the exact same thing when I plug in this negative x, then yes, my function is even. So let's see what happens. When I plug in this negative x, I have negative 3 times negative x squared plus 4, which is equal to negative 3 times negative x is simply going to be x squared plus 4. Thus, we end up with negative 3x squared plus 4. Notice that the functions are completely the same, meaning that yes, this is definitely an even function. Okay? Now let's try a different one. Let's say that we have a function f of x is going to equal to 2x cubed minus 4x. Like I said before, we are first going to assume what we want to know or what we can identify. In this case, we know that our leading coefficient is 2. Our power of x is 3, meaning that this 3 is odd, so we might have an odd function. The other thing that we know is that our odd function ends up completely opposite when I plug in a negative f of x. What that says is, what happens when I'm going to plug in this negative f of x? My goal, or if it actually is an odd function, I should get f of negative x, which is equal to negative f of x, which is, like I said, the complete opposite, meaning that I would want to end up with a negative 2x cubed plus 4x. Notice that the only difference is that this 2 was here positive, now it's actually negative, and this 4 was negative, and now it's positive. So like I said, it is completely opposite. This is our goal. This is what we want to end up with. If we actually end up with something like this, then yes, my function is odd. So let's test it out. If I plug in this negative x, I have 2 times negative x cubed minus 4 times negative x. Negative x cubed, so I'm going to have a negative x, and a negative x is going to give me a positive x, times one more negative x. This is going to turn this whole thing into negative, meaning that I have negative 2x cubed. Negative x times a negative 4 is going to be plus 4. And if you notice, this is exactly what we wanted. We wanted a negative 2x cubed plus 4, which is exactly what we got. So yes, this is an odd function, just like we assumed. Now lastly, let's just try one more example. Number 3. Let's say that we have a function f of x is going to equal to 2x cubed minus 3x squared minus 4x plus 4. Again, because we see that the power of the x right here is a 3, we are going to assume that this is an odd function. Because it is an odd function, I know that my goal, or the end that I want, is just going to be completely the opposite of this, meaning that it's a negative 2x cubed plus 3x squared plus 4x minus 4. This is what I want to end up with. Okay? Let's actually test it out. If I plug in f of negative x, what happens? 2 times negative x cubed minus 3 times negative x squared minus 4 times negative x plus 4. Like we did before, this negative x cubed is simply going to push a negative out, meaning that I'm going to have negative 2x cubed. X squared turns into a positive x, so I'm left with negative 3x squared. Because this one turned into a positive, negative x times negative x is just negative, it's just x. Okay, so we end up with this negative x cubed. Then we have a negative 4 times a negative x is going to be positive 4x. And finally, we have this, which is plus 4. Now, let's compare them. If we notice, we have a negative sign, we have a negative sign, we have a negative sign, we have a positive side right here. We have a positive, we have a positive, and we have a negative, a positive and a negative. So for two of our cases, which is going to be right here and right here, which is right here and right here, the signs are opposite, meaning that no, this is not an odd function. So this must be a neither.